Hello, everybody. Welcome to the Somnia Agentathon finale. Hopefully, this is the moment that you guys have all been building towards. Hello, I'm Giles. I'm from Encode, and I'll be hosting today. I am buzzing, really, to see what you guys have been created throughout this entire hackathon. And first things first, a big congratulations to every single one of you guys who took part in this. Whether you're pitching today or not, whether you're joining just to see who the finalists are, you've built something that is something that's fantastic, something that's real and very good during this hackathon. So this is not no small feat to have done. So give you guys a round of applause for that. Let us know in the chat where you guys are joining from, how you found the hackathon, and if you're a finalist, let us know which project you're joining from as well. Obviously, a very big congratulations to our 10 finalists. You rose to the top of a very, very competitive field today and throughout this hackathon. So huge congratulations to you guys. You built something awesome. A note on how the finale is going to work. This is going to be, I think all the pitchers, you guys should be aware of who is pitching in which order. And most of you joined the practice session yesterday, so you should all have your presentations ready and things like that. And 1 second. Awesome. So we have the order. I'll put it the order. Actually, I'll copy the order into the chat here, so that you guys are aware of who's pitching in which order, just in case. There we go. That's the order. You guys should already be aware because I've emailed you. But the format of this, we'll do 3-minute pitches each. Just a live presentation, talk over it, share your screen, things like this. Make sure you guys are ready and you know which order you're going to be picked up in. And then I think we'll do a bit of feedback after each pitch from the Somnia team, from Anjali and Paul. And then at the end, we'll do the announcements of who's won the prizes. And then that is the end of the hackathon. But I will now hand over to Paul or Anjali, who's going to be doing a bit of an overview and a congratulatory speech to you guys.
Yeah, I can do kind of so the reason why we did this Agentathon is we were trying to find projects that were using new pieces of our technology. We built this new tech stack recently and we were really interested to see what developers could build with it. So it was really cool to see all the different projects coming out. Very excited to do the judging today. It's going to be awesome. The other thing we're looking for is to find an individual contributor who actually we're looking to hire. And so the process there, we're going to find one of the best projects. If they're an individual contributor, they're going to go into a hiring process and potentially get a job with us and work with us as a demonstration engineer. So that's going to be cool as well. It's a good way for us to find quality talent as well.
Awesome. Anjali, anything to add as well?
Yeah.
Have you found the hackathon?
During the entire process of the hackathon, I think I saw the participants doing great works, and I would say that the quality of projects has been amazing. Like the ones we've evaluated, and of course there are multiple things which could be done using Somnia agents, but what we have achieved, I mean, use cases right from security and security protocols, and involving prediction markets, gamified versions, and it was simply amazing. The UI, the way because it was, of course, as we mentioned, there is hiring opportunities. So I was really amused to see the kind of good presentations and demo videos. All of the participants have done the hard work, which is put in by everyone. And so I'm looking forward to all the pitches today. But yes, good done, everyone. Congratulations.
Perfect. All right. In which case, I think we are ready to get started. We will start up with project play scripts. So that is going to be D. I'll invite you guys, same as yesterday, the practice session. I'll invite you guys all up to be participants and panelists, and then you can go for your talk. Okay, D, I'm inviting you up now. Hopefully you can see that. Awesome. I see you've accepted that. And then if you just share your screen, unmute yourself, and then we can see your submissions. Hello, D. How are you doing? I think you're currently on mute. Oh, good stuff. Nice. We can see your screen.
Hello, can you hear me now?
And we can hear you. Well done. Awesome. You have 3 minutes to take it away with your pitch. Looking forward to it. Off you go.
Okay, all right. So, PlayScript is a sports prediction platform, an agentic sports prediction platform, right? And the difference between PlayScript and traditional sports prediction platform is how it works. So, in traditional sports prediction, users pick binary outcomes, right? Which teams are going to win certain matches, or which teams are going to score specific goals. And in the loop of this, for these markets to actually get resolved, someone or a bot off chain needs to be able to get this data in real time in order to resolve this market correctly. And on PlayScript here, this is abstracted through the use of Somnia agents. So usually there's like a fix for this, where we have oracles like UMA, which is like an optimistic oracle where people can run their own individual bots to assert answers for these predictions. And these work with platforms like Polymarket. But this introduces like a capital efficiency issue, because these bots usually need to stake certain amount of bonds in order to make assertion for these event results. But that can actually be taken away through the introduction of these agents, right? So what PlayScript does is a user goes to a platform and sees a list of fixtures, which is basically upcoming sports from upcoming matches for different sports, right? And this is totally permissionless, meaning every user can register these matches, make their predictions on it by picking a group of multiple outcomes. So unlike other prediction markets, we don't just say who wins certain match. We let users build a script which contains a list of possible outcome for these matches. And once this match is registered, it's registered with an ESPN endpoint, which is like a public endpoint for getting sports data results. ESPN is a very reliable source, which a lot of big players in the industry falls back to. So reactivity is also used in this case. So the moment a player registers a match, it locks in the timestamp for the kickback predictions up until this time. And once reactivity fires, no one can make predictions during the kickoff, which is the match period. And after this happens, Somnia agents actually, the reactivity triggers and calls Somnia agents for settlement, which basically takes the ESPN endpoints used to register each of these matches and looks up the results for whatever sport that was, and tends to grade the outcome by scoring which teams won, how many goals were scored, how many penalty cards were given out, and how many oversides or the different things that happened in these matches. So there's literally no need for a human intermediary to come in to resolve this, right? The market life cycle is actually quite easy. Every user comes here, they register a match, which uses the ESPN endpoint, as I mentioned. Users lock scripts using play tokens. So they basically lock scripts with their selected outcomes of what could possibly happen in this match. And once the kickoff fires, the market locks this script and no stakes can be placed again. And when it's settled, agents fetch ESPN data and the kernel grades all 15 legs, which are basically all 15 outcomes of the matches. And whichever one a user actually played gets resolved. And then there's the claim process where users can actually claim their payout. So this is actually a very good use case, the agents here, because it makes anyone able to launch a prediction market with publicly verifiable outcomes. So there's no chance for manipulation or wrong play in this. Everything is actually quite trustless in this system. So yeah, that's play script.
Awesome. Thank you very much, Dee. Great presentation and sounds like a great project as well. And Charlie or Paul, do you have any sort of feedback, or do you want to move on to the next?
Yeah, quick question about how does it look in terms of the construction of the legs? I don't know whether you've got a picture of the app or something that you could just show quickly.
Okay, the legs construction. I think I share like a demo on the platform. It's basically kind of like every possible outcomes that could happen in a sport. So let's say for a football match, there's obviously going to be a winner, and then there are like options for over certain outcomes. So people could actually play over 3 goals, over 5 goals in totals, or you could play under 5 goals or under 2 goals in totals. You could actually pick outcomes like if there'll be a penalty in this match, how many cards will be given to which team,
Sorry to
if the away
interrupt.
team.
Sorry, but we can't see the demo, I think. The screen is
No,
frozen for us.
I do not have an illustration for how the
Okay, no worries.
legs look, so
Okay,
that's
okay,
why.
all right. Okay, cool.
Yeah, so yeah, the legs are basically all possible outcomes that could go on in a match. So these are the outcomes that you can verify through the ESPN endpoint. So they are all public data which anyone can see through a match, like who won, who did what players scored what number of goals. So you can actually make predictions on if a certain player would actually score this number of goals, or a player would not score any goal, or which players would actually get set aside. So these are actually all data that can be verified through ESPN.
Cool, makes sense.
Nice. Okay, perfect. Well, thank you very much, Dee, for that one. We will move on to the second pitching now, which is Veritas. So this is OJ. I will invite you up now. Nice. I see you rejoining. Hello, OJ.
Yeah, I'm sharing my screen right now.
Nice.
Okay. Hi, everyone. I'm OJ. Every smart contract can move money the instant a condition is true, but almost none of them can tell whether the condition is actually true. In blockchain, we built an oracle or a multi-sig or a vote, and we call it decentralized. It isn't. There's always a trusted human or a trusted server in the middle of every real-world decision on chain. A market needs to know if Bitcoin actually closed above $100,000. A DAO dispute needs to know which side is actually right. And that is why we built Veritas. Different products, one missing piece. A judge they can trust that lives on chain. Veritas is one solidity contract. A consumer calls it with a plain yes or no question and adds a few evidence URLs. It never touches an AI. It just trusts the verdict that comes back with an on-chain receipt. And here's why it has to be on Somnia. When I fire a request, 5 Somnia validators run a query off-chain. They scrape the evidence, reason with an LLM, and vote. The judgment runs on the validators, not an oracle I'm asking you to trust. While building Veritas, a first version broke. A bot-protected price page scraped differently on each validator. So a 2 of 3 majority couldn't form. So I moved Veritas to a 5 validator and a 3 of 5 threshold. I ignored the failed scripts, and now anyone can fire or refire a stock verdict. Now, this is the part no other chain I've seen can show. That's the validator receipt for an on-chain AI reasoning or decision. The chain of thought, the model confidence, and the exact value it's extracted. 5 signatures with 3 or 5 agreed. If Bitcoin or is Bitcoin above $100,000, Veritas resolves no. Is the edge round? Resolves yes, with the model 95% sure. Real stake pools and real payout on testnet. Veritas is one primitive contained in 3 apps. A prediction market where Veritas resolves the bets and winners, split the pool. A plain English insurance vault that pays out when the AI confirms the condition, and a DAO resolver that reads both sides and releases the bounty to whoever's right. Veritas isn't another AI prediction market. It's the contract that all of the 3 apps sit on. Veritas' subsequent finality makes sure payout lands the instant a consensus forms with low gas, so the cost per verdict is tiny. I shipped Veritas as an SDK, so the next person doesn't have to start from scratch. Veritas is live now on testnet, and we're hoping to ship on mainnet soon. A very big thank you to the Somnia and Encode Club team for organizing this Agentathon and considering Veritas good enough to make it to the finalist. Thank you very much for listening.
Very cool.
Awesome.
Yeah, I think you've chosen, I think prediction markets are a very good use case, but I think what's really nice about your project is you kind of thought about almost like an infrastructure layer that can then support lots of other projects. I think my question is about, so would you, if you were to take this to market, would you focus on developers, or would you try and build a first party set of applications first to prove it and show how it works? Kind of what's your thinking there?
If we were to take this to the market, firstly, we would ship to developers to test the product out properly. Then make sure we get everything right and secure, and then ship to the market the next. So
Yeah, makes sense. Cool. And then yeah, this is very interesting. So then in terms of the app, you built the kind of infrastructure layer and then some kind of proof of concepts around different elements. I think if I would ask you, what do you think is the killer use case? What is it? Do you think it's prediction markets, insurance, disputes? Yeah, what do you think is the killer use case in your mind?
I would say all of them come together to complement one another. For example, the prediction market helps make sure windows close and anyone can trigger the resolution. But the one that stuck out, the application I really would go for is the prediction market, actually, because that's the trend right now, basically.
Yeah, cool, nice, awesome. Yeah, very cool, very nice project.
Perfect. Thank you very much, OJ. Great project there. And we'll move on to the next one, which is Aegis, and this is Yale, who's just joined as a panelist. Hello, Yale. How are you doing?
Here.
Nice.
I'm fine.
Perfect.
Hi everyone, I'm Igor from Aegis. Decentralized insurance already exists, but it doesn't scale because a human committee votes on every single claim. That's slow, it's subjective, and it decides who's allowed to underwrite. Aegis replaces that committee with an on-chain AI committee. When a protocol gets exploited or a stablecoin breaks its spec, 5 of Somnia's native AI agents judge the evidence. The oracle takes the median. NF includes the bar. The policy pays out. There is no human in the loop. In 3 steps, the watcher detects the loss and puts the evidence on chain. Then 5 validators each score 0 to 100, and the median decides. The payout settles itself. There are 2 things that make this safe. The AI only decides whether an event happened, and the fixed on-chain formula decides how much. So you can never claim because you never get more than your real loss. And it's a real marketplace. Anyone can buy cover, and anyone can supply capital to the pool, earn premiums, and back payouts. This only works because claims settle objectively. And it actually works. I ran 2 events live on Somnia testnet. A real 100% whole drain, the median is 100, paid out. A harmless 2% deep, and the median is 50, no payout. The bar cleanly separates a real loss from just market noise. The AI generally decides. And the core is built once. New risk is just a stored prompt. There is no redeploy needed. I even added one after launch. And it all runs in Somnia's native AI agents, so this product can exist without an on-chain AI. It's built, tested, and live on Somnia testnet today. And that's Aegis. Insurance that sells itself by AI consensus. You can try it live today. Thank you.
Very cool. Yeah, very much a use case that when we were building agents, we were thinking about. I'm interested to know, how does the agent, does it just look at kind of the cash levels in a vault and go, all the money's gone, there must have been some kind of breach payout, or how does it kind of do that determinism?
Yeah, so on-chain consensus is being triggered with a watcher that just watches the pools, and all the on-chain evidence goes to those on-chain validators, Somnia's agents, straight from on-chain. So yeah, the data can be manipulated or anything else exploited.
Yeah, cool. So there's that. And then, so what the other interesting idea is this kind of idea of a two-sided market. So would you imagine liquidity providers would say, I'm willing to insure this kind of query, and then the market would get created, and then people can essentially buy that insurance off them if they want to? Is that how you're kind of seeing it? Or would you see buyers would like insurance for this and LPs come in? How did you make that two-sided market?
Yeah, so basically you can just provide LP to the pool, and well, insurance is capped by that amount of LP provided in the pool, so you can be insured by the greater amount that is already in the LP, actually.
Yeah. So more my question is more, how does that market work? Do the LP providers have to come in first and offer the markets, or can a buyer be like, I would like a market on this? How does that work?
Well, actually, protocols owners can like connect their protocol to the app, and it goes from then.
Okay, cool. Right. So the protocol owners themselves are the initiators of the markets, because they're like, I'd like to offer insurance on my application. That's a good idea. That makes a lot of sense. That's cool. Yeah, very cool product. And then it auto pays out as well. Yeah, you talked about that as well. There's a function that basically determines the amount drained and then auto pays out. That's very cool as well. Yeah, nice product. Very cool.
Nice, thank you very much, Yale. Another great project. Next up, we have Marshall from Signal Vault. Who I'll invite up to panelist. Project number 4 coming up now. Marshall, if you're with me, I've just invited you up. Oh, sweet. I see you've joined.
Yeah, I hope I'm audible. Just give me a second.
Yep, we can hear you.
Perfect.
And we can now see your screen. Nice.
Right. Hey guys, I'm Marshall, and I'm here to present to you about Signal One. So here are a few problems with copy trading. The most important issue with copy trading is people really have no idea about the reasoning behind every single trade. And there are a lot of trust and manipulation risks when it comes to copy trading, and which leads to a huge amount of losses over the period of time. So this is the reason why we wanted to build Signal One. Signal One is basically a project where you can create your own vault, and our agentic pipeline starts inserting trade signals and also the reasoning behind all those signals. Now people can subscribe to this vault directly, and once they do that, the wallets which are associated with it starts making trades on DreamDex by mirroring all the signals which come into the vault. So here's a use case. Like we have Arjun over here, like he's copy trading by looking at a trader without knowing the reasoning behind every single trade, and down the line he starts to lose a lot of money. Now using Signal Vault, he basically gets to know the reasoning behind every single signal, and he makes informed decisions based out of it. Now 3 months later, he can set up all the restrictions and so on our application. This makes sure that he doesn't lose any money at all. So here's a UI. You can view all the vaults present in our application. Once you click on it, like you can view the stats, the current signals of the vault. You can view all the recent signals and subscribe to any one of them. And this is one of the cool feature we have. Like you can view the entire audit trail of a specific signal, and you can also deploy your own strategy vault, as I mentioned earlier. So you can set up the vault name, strategy prompts, the risk parameters such as performance fee, max drawdown, and so on. And once you start deploying, like 8 different contracts are deployed along with the subscriptions and initial funding for a specific vault. And the agent pipeline starts to finally produce and send signals into the vault. And all the wallets that are subscribed to a specific vault starts mirroring all the signals in Dreamtex. Now, the entire application is powered by Somnia's various integrations. Like we have 3 different agents, such as JSON API agent, LM Power Subset agent, and Info Tool Chat agent. So we're using Somnia's reactivity to basically, take the signals from the vault and perform trades in Dreamtex within the same block. We're using Somnia's data streams to get and update the performance metrics, and Dreamtex to basically make all the trades. So this is how the signal pipeline looks. Like you have the JSON API agent fetching the market data, finally sending to the LLM parse agent, which gets the fear and greed index and also some of the market news. All these are finally sent to an inference agent, which makes the final decision, and the signal is sent to the vault along with the reasoning. So once the signal enters a vault, all the wallets to subscribe to the vault starts mirroring all the trade signals on Dreamtex using the mirror reactor contract, which is out there. And we're using reactivity because it uses a lot of risk protection, and also there are a lot of automations which are associated with it. Finally, we have the Somnia's data streams, such as mentioned over here, which we're using to fetch and update some amount of data. So this was Signal Vault. Thank you so much.
Very cool. Yeah, when we built all these component parts, one of the products I wanted to see was something like this, which is like a algo trader, which then people can subscribe and copy trade with. That's very, very cool. A couple of things. I'm very interested to know the trading strategies. How have you found those have worked based on kind of, you give it some natural language and it creates a trading strategy? Have you found that works well, or have you had issues there? Because I think that's normally the tricky part that I've seen with these kind of products before.
Yeah, so let me just give you a background on why we started this project in the first place, because we faced a lot of issues while following copy traders on Discord. And we tested this out by giving it out to our own friends in the same Discord channel which we had, and they were using a bunch of test strategies to test out all the agent performance metrics. And to be quite frank, we've seen a reduction in losses to around 20 to 30% than they were facing earlier. So that is how we decided that something like this might work out really well.
You actually come up with quite an interesting feature idea there as well. So if you want to copy trade someone on Telegram or Discord, you could use agents to plug into the Discord chat feed or the Telegram chat feed and then basically auto trade for you rather than you having to manually place the trades if you want to copy trade someone. That's actually quite an interesting feature. I'm going to note that down for myself for something for the future. Yeah, very cool project. I think I really like the way how you used loads of the Somnia tech stack. And I could definitely see this being valuable in the ecosystem.
That's amazing. Thank you so much.
Perfect. Thank you very much again for that one, Marshall. I'm inviting up Thomas yet, who's going to be joining us from Project Curie.
Yeah.
Hello, Thomas. Nice.
Oh, did I share the wrong screen?
Right. Marshall, we need to. I think you need to leave. I can try and kick you out.
All right.
York.
All right. Hi, everyone. My name is Thomas Pugh, and I'm here to share Curie, a protocol built to autonomously mediate drug coverage disputes on Somnia. So currently, drug coverage negotiation is a lengthy and expensive process. Prior authorization can cost providers up to $10 per transaction, and physicians can spend up to 13 hours a week reporting. The denial appeals process can also drag for 30 to 60 days. Only about 11% of denials get appealed, even though over 80% of appeals result in overturn. Furthermore, with lawsuits against payers like United Healthcare reporting up to 90% error rates in automated dispute systems, AI in drug coverage has exposed the risk of opaque systems controlled and centralized organizations. As healthcare organizations increasingly employ autonomous systems, the authorization process needs a neutral, trustworthy mediator to enable dispute resolution. So this is where Curie comes in. Curie is an AI native protocol for mediating healthcare coverage claims. All evidence, reasoning, and ruling is hash committed on Somnia, keeping verifiable content with zero PHI on the chain. With efficient neutral arbitration and one shared contract for every step, from filing to appeals to payment, both sides resolve disputes with total transparency. Curie relies on Somnia's 100 millisecond blocks and sub-second finality, and using Somnia's agents, LLM consensus drives the on-chain ruling. Using the LLM parse website protocol, contracts can pull and verify evidence such as FDA drug labels for treatment. Then, after that, the LLM inference weighs the evidence against payer uploaded policies to deliver a verdict, potentially requesting further evidence on chain and entering a feedback loop. Every step of the process is verifiable. Evidence is hashed and stored on the chain for verification, de-identified from the patient. And every round of the dispute process is tracked as an on-chain state transition. From claim to payment, coverage is guided and audited. I wanted to thank you all at Somnia for making this possible, and thank you to everyone for your time.
Very cool again. Not a use case that we thought about. Well, we thought about like insurance and kind of resolving insurance, but this is a very specific version of this, which I think is very interesting. And clearly, you articulated the problem at the top. Clearly solves a problem in the market today. I think my big question is about how did you find the LLM resolution? So, do you think disputes would actually get resolved correctly? How did you find that when you were running your kind of prototypes, and how did you see that going?
So to be honest, I think there's a lot of work to tweaking it. A lot of this is, as I found, the use of the available agents, they can be inaccurate. And so, especially in healthcare, I think there's still a lot of work being done to make the models and also find proper prompts to properly resolve disputes. So I don't want to claim that I'm solving the 90% error rate, but I wanted to push in a direction that's saying, we want transparency so that these systems are hosted on chain and the auditability is there.
Yeah.
So yeah, the accuracy isn't necessarily there, but I think it can go in a direction where it will be.
Yeah, cool. Yeah, I think for now, what we've seen, the primary use case with the agents tech is when there's like a hard number, there's a hard piece of data on chain, and then that's a very clear thing to resolve. When you're doing kind of more loose resolution about a piece of text and interpretive stuff, that's where it gets a bit more tricky. I wonder if there's a solution in the interim where you still have some human loop, but the record and transparency is still on chain, because I think that's still quite valuable and quite interesting. And then with the support of LLMs, until LLMs get to a place where you get to that 90%. But yeah, very cool project. And yeah, I could definitely see if you could get that to work, would be very valuable.
I appreciate it. Thank you, guys.
Nice. Thank you very much, Thomas, again for that one. Who do we have next? Up next, we have Veralaunch. So this is Surbit, who I'll invite up now. Oh, I did. You're right. I did miss Mike Drop. Okay, Mike Drop, you'll be on next.
Hey guys, hi. Is my screen visible?
Yep.
All right. So, hi, I'm Surbit, and this is Veralaunch, an autonomous AI-verified token launchpad on Somnia's Agentic L1, a launchpad that runs itself. Let's start with the problem. Every year, rug pulls drain billions from token buyers, and here's how a typical launch actually plays out. So, the project team takes the raise and just vanishes without the deliverables that they promised, and investors just get nothing in return. So, what's the solution? Well, it's Vera launch. Here, buyers invest and the money locks in escrow, and Somnia's on-chain AI verifies real milestones against public evidence like mainnet deployments or audits, and so the funds are released only after those proper checks. Then on the buyer side, we have an addictive swipe feed to discover and back new project launches, and two strong AI signals for buyer protection. Number one, every project carries an AI trust score, and every wallet gets an AI Sibyl score to keep bots out. Like you can see the swipe working on the right side of the slide. Then, that Sybil score means one human, one allocation. Somnia's JSON API agent reads your wallet's real on-chain data and derives a humanity score. Like a score of 85 can be seen here as an example for a wallet. Then, best part about Vera Launch is that the platform runs itself. It has an autonomous keeper agent that scans the Somnia blockchain, invokes the AI, and settles everything on-chain. Now, we are having this agents feed on our portal. So this is that keeper agent activity, which is showing that every line here is a real on-chain action, and the keeper invokes and the Somnia AI decides. Now, moving toward the Somnia AI stack, so every decision runs on the three Somnia agents, the JSON API agent for the Sybil score, an LLM pass website agent for evidence, and an LLM inference agent for the verdict, all settled by the on-chain consensus. Now, let me show you one real example. This is an actual Somnia receipt, and we point the LLM pass website agent at any project site and ask it to judge that project, like you can see in the image here. Now, we have a language model, Qwen3, that runs on-chain, weighs the evidence, and gives a score based on the source. And this is the criteria for releasing a project's funds for any milestone. Like here, you can see the reasoning being used, and as well as we have the confidence score here. Then we also have external AI agent support. Any AI agent can use Vera Launch to discover projects and back a launch on its own. Like you can see in this slide here, that external agent is doing that. So that's agentic L1, agents building on agents. Well, this is Vera Launch for you. Thank you. You had a really nice time working on this project and with Somnia.
Yeah, very, very cool. And I felt this problem myself as a Web3 participant is definitely a big problem. And I think using AI to help verify the trustability of a counterparty is something that's potentially incredibly useful. And when you're doing token launches, that's very interesting. So can you give me a little bit more detail on how you did that so far? I think one of the things that would be really good is the ability to integrate Twitter, which is a feature set that we're adding, because then you could kind of have people's social handles linked and see if they're a reputable person. I think that'd be quite interesting. But how did you kind of look at that reputability score? Can you go into that in a bit more detail? You had one slide in it quickly, but I'd like to know a bit more.
If you are referring to the wallet score, currently we use just the on-chain data and like on-chain signals for that. But like, yeah, like the suggestion that you gave about using the social handles, that's actually a pretty strong thing and would definitely help this one. And
yeah, so at the moment,
yeah,
sorry,
yeah, please go ahead.
No, so at the moment, do you just use the wallet information or is there more information you use?
For the on the user side, it's just the wallets for now. But on the project side, we are actually using a lot of thing where the Somnia LLM actually comes in, where we kind of like feed it all the public evidences and like whatever info is available about their project, and then we have that trust score coming in. So there we get whether they are actually doing it, whether they are eligible for passing that milestone or not.
Yeah, makes sense. And then how's that trust score calculated? Is that just the LLM deciding how trustable it is by looking at the website and things like that?
Yeah, like we gather a lot of public sources, verified sources, and feed in that to our LLM, and then it generates that score for us. So, yeah, there are a lot of things that will be needed to make it actually better tested, but it's like definitely better than the bare minimum that the other launch pads use.
Yeah. I think this is a really cool idea. I think with more time spent on thinking about that AI verification, maybe adding some the social handle stuff. But yeah, I think it's a cool idea. It's a very nice project.
Thank you. Yeah, I really liked your suggestion about the social handles. That's actually very cool.
Awesome. Thank you very much, Sorbit, for that one. I'm sorry, Kalpi, I missed you previously from Project Might Drop, but I'll invite you up now, and then we'll head back into the correct order. So now we have Project Mic Drop with Kalki.
Yeah, hi.
Hello, Kalki.
Yeah, wait, I'm facing some problem in sharing screen. Let me rejoin.
Okay, I'll come back to you. In the meantime, let's move on to Lictor, and that's Tim, who's next up. Where's your participant? Tim, can you just drop something in the chat so I can find you quickly, please? Oh, got ya. Perfect, thanks.
Hey, hi. Wait. Is my screen visible now?
Yep.
Okay. Hi, I'm Kalki,
Okay,
and
cool.
this is Mic Drop. Okay, let me start. Hi, I'm Kalki, and this is Mic Drop, an on-chain creative battleground for AI agents. So everything you're gonna see here, voting, scoring, performance, everything lives live on-chain Somnia. So let me tell you why this was hard and why it matters. So there are three, like everyone says on-chain AI, but nobody really means it because there are three gaps. First, unverifiable AI outputs. When AI writes or scores content, you only have the operator word that the model really produced, but you really don't know. It has fake autonomy and no real stakes involved. Once you close a tab, everything is gone. Mic drop closes all three gaps. Introducing mic drop. So idea is you're gonna deploy an AI agent with the personality of your own, and in pool it will match with some other agent, and then it will have a battle on rap, roasting, or pitch, anything, and it settles automatically. So think of it like a fight club for AI agents, and it operates on its own. So how it works? First, you're gonna deploy your agent with your custom personality prompt by submitting 0.5 STT, and it registers on chain. Second, battle happens autonomously. Using Somnia's on-chain LLM, it writes its own script and versus what it gonna say in that battle, and with three validator majority consensus, and AI judge scores the output, like how it performed. Next, stake and settle. The crowd stakes STT, like they do betting, like I think this will win, this will win. And the winner is decided on the basis of 60% what AI judge did and the 40% upon the audience poll. And in the end, winners get auto payout like from the pool. So this is a very small demo. That's how it looks. So this was a very small demo how battle happen and how you can vote like whom you want to support. It's all happening in a 3D arena. So three things make this only possible on Somnia. First, it is trustless by design. Every agent call logs on-chain consent receipt, which validator ran out. For example, if you voted scores, your comments, everything get registered on chain. You know exactly why this happened and who was responsible for it. Second, real stakes, real reward. Premature SCT betting winners get, like the side who wins will get 85% of the pool amount on the pro rata basis of the amount they staked. The winning agent creator earns 10% so that we can also support creator economy, and 5% goes to the house. This all lives on chain forever. Second, it runs itself forever. Like it doesn't have any backend. It's a keeperless loop runs via Somnia activity. So chains run automatically, indefinitely without any problem, and it is also a self-healing. So what's next? Mic drop is just getting started. So what I'm gonna add some new battle formats like techno events and agent marketplace, more tournaments, and more ways to monetize creator, and then finally move it to mainnet. So yeah, this was mic drop. You can scan this QR code to go to the code or test the live web app. It is live on Somnia testnet. Mic drop shows how trustless can be a competition. Thank you.
Very cool. I really like the entertainment angle you've gone for, which I haven't seen people use agents a lot for that. But we had this idea again when we were building it about agents kind of battling each other on chain. And I like the motif you picked in terms of like rap battles, because obviously text is pretty easy for LLMs to generate. I'm kind of in your mind for the end user, like I'm trying to understand who do you see kind of using this, and what kind of emotive problem do you think they're trying to solve, and they're kind of really interested to use this? Because I think it's a really cool idea, but I'm trying to pair in my head is like what customer would come and kind of use it and be really interested in it. And maybe you can make it really degen and go for like crypto degen people. Yeah, what was your thinking there?
So like what I think is it's mostly based for fan markets. For example, some famous guy creates their AI agent and they're gonna battle it. So their fans can watch it and do betting, like how it happens. So I'm thinking to expand it on fan market also in the. I'm also adding one more feature in it for techno support. So you will be doing same thing for the AI agents, and they will be, instead of doing rap battles, they will be playing techno musics. So people can hang out in the live arena. They can watch it. They can feel it. Like it's a live stream, so they can feel it. They can do betting. So it's kind of a whole fan ecosystem where people come and enjoy, see the battle, and see how what AI can do. Unless of doing our normal stuff, it can also entertain us.
Yeah, I think that's a very cool idea to get key influential people. Like you can imagine crypto KOLs to start, because you focus on a Web3 audience, and then eventually get like mainstream famous celebrities and stuff, and they have their agents. That's quite cool. And then in terms of the AI judging, how does that work? How does it determine who it thinks is better? Is it just how does that work?
So I added AI judging because like I want to be completely transparent. One part is like I added human votes, and the other is AI. So my whole idea was narrative around the AI. So I want AI to also judge how it feels. So that's why I added AI with it. But yeah, like I think it depends upon the user feedback. Like if I say, because in starting I don't have that much user base, so no fight will get resolved without any votes. So that's why I added an AI layer, so that fight will automatically continues and get resolved. But also I'm thinking of increasing the weightage of user votes by the time I get more users. So that's what I was thinking.
Yeah, that makes sense. It's cool. All right, nice. Yeah, awesome project. I really like the entertainment angle. I think I could see, it being taken a lot of different directions. Very cool.
Thank you.
Nice, thank you very much, Kalki. Next up, we have Tim from Lictor, who I think you've actually already joined as a panelist. So if you'd like to unmute yourself and try and share your screen. No, awesome, well done.
All right. Sorry. Okay, so everyone. Okay, is my screen visible now?
Yep, all good.
Right. Okay, everyone in this room has had a trading thesis, something like if Bitcoin drops below this price, or rotate my funds into probably buying Somi. So that's what we basically talk for. It's just basically say what you want, and the chain does the rest. All right. So we see it here. So it runs 24/7 on chain, and you don't need to run bots or run cron jobs for you to like monitor price of anything or babysit, or rather have bots to monitor trade executions. Okay, so later closes the gap. You write your thesis in plain English. On-chain AI agents break it into conditions, if and if not, and then watch the signals. So you can plug in any price feed, any JSON API, even a prediction market, 24/7, and then it execute the trade on index. No code, no servers. You keep your keys and literally control the budget you assign to it per trade. So it runs on these four steps. Okay, so it's live on Somnia. Sorry, it's live on Somnia mainnet today and publicly verified. So it's not a mock-up. It's not. Yeah, we had the testnet version where we tested for reactivity on the mainnet. We didn't deploy the contract because I think it requires 32 summit to make the reactivity keeper being active. So anyone can read any line of code on our mainnet contract. All right, so here we have a real trade that was executed. So I placed the text buy wrapped so if Bitcoin falls below 70,000, then I allocate the amount I'm willing to risk. The signs the transaction. It already has the token contract, so it doesn't buy a wrong token or anything. And we can view the um, receipt here on chain. So buy route to Bitcoin falls below 20,000 USD, and the inference went through. Each of the receipts are similar, and the you can compare. All the receipts are identical, so the execution went through. Okay, so why did we build this on Somnia? Okay, so the AI decision lives on Somnia because every other place where you want to run AI agents is like a black box. So the model runs off chain and you're trusting some of chain server. So build this because it runs better on Somnia, and then Somnia runs the model on its own validators at zero temperature and reaches the consensus on the exact output. So the decision also is itself on chain in a signed receive like the one I just showed you. So like I said earlier, also it's currently using keypad. We are using keypad to like schedule the endpoint. Also, it's permissionless. You can trigger endpoint yourself, but it's currently being triggered like to fire the conditions. So the next version will just come in when the mainnet contract for the reactivity is deployed. So for self-scheduling via reactivity. So simply say what you want, and then the chain does the rest. Because on other apps, you basically have probably making decisions at the right time or at the time you need to make those decisions. But yeah, you can like make decisions in 10 minutes time, in 10 days time. So anytime the decision gets executed, you get your outcome done. Thank you, everyone.
Very cool. Nice project again. I think, yeah, one of the use cases that I think we were thinking about when we were building all this tech together is kind of helping people automate their trading because ultimately they don't want to sit at a computer and look at prices 24/7. How does the LLM decide the venue to make the trade on, and how does that work? Because obviously a user's account, I have different accounts everywhere, I have wallets. Yeah, how does that work basically? Can you run me through that in more detail?
All right. It has the conditions. For instance, in this place, we place the Polymarket API and the CoinGecko API. So saying buy wrapped some if Bitcoin falls below 70,000. So once Bitcoin falls below 70,000 and the keeper knows price has fallen below that, it then rotates the fund. You delegate USDC. So it rotates the fund from USDC into a DEX, then buys wrapped some for you. And yeah, it works that way. So it goes through a DEX to route the swap when the infers to chat fires.
Yeah, and then how does the user choose the dexes, or does it just automatically have the dexes linked up? How does that work?
Okay, it automatically have the dex, but you can set slippage and set other parameters for like more flexibility.
Okay, cool. And then what dexes does it currently support?
Oh, okay. The dex I used was it's actually hard coded like to swap directly into the contract. So it's like takes the token out and then swaps it in.
Okay, cool. Makes sense. All right, nice. Yeah, very cool project. I think, again, very useful for people because I don't want to sit 24/7 watching screens. And if I could just get an LLM to execute trades for me, that'd be very useful.
Thank you.
Nice. Thank you very much there, Tim. Aditya, I think you've already joined as a panelist. If you'd like to unmute yourself, and then we can get kickstarted with your one as well.
I think he needs to
Oh
stop
yeah,
his
Tim, you need to stop sharing your screen.
Yeah, okay. Hi guys. So this is Aditya and I'm presenting Colosseum. What if AI agents didn't just help people trade, but what if they trade against each other for real money and everyone else could bet who wins? That Colosseum, the first fully on-chain AI versus AI trading arena built on Somnia. Almost every AI plus crypto project puts AI beside the user as a co-pilot. We asked a different question. What if AI could become the player instead? Two autonomous agents compete, spectators bet on the outcome, and another AI acts as a bookmarker to set the odds. From start to finish, no human ever decides a trade. And here's how it works. You pick a fighter, degen, the whale, the quant, and more, and each with its own trading personality. Every round, both agents analyze the market and independently decide whether they want to buy, sell, or hold. Their orders execute directly on Dream Decks. Their portfolios update in real time, and every move is transparent on chain. When the duel ends, the higher PNL wins the pot, and everyone who backed the winner shares the reward based on the live odds from the AI bookmaker. Instead of watching charts, you're watching strategies evolve itself. And this isn't just a prototype. 14 on-chain duels and 75 autonomous trades has already been done. Every transaction is verifiable on Sonia. Pick any transaction high on screen and you can check yourself. That's the credibility that doesn't come from art, it comes from the blockchain itself, right? And here's the architecture behind it. The front end talks to the arena contracts directly, which orchestrates every dual on chain. Those contracts integrate directly with Somnia agents for the AI inference, Dreamrex for the trade execution, and reactive contracts that automatically progress every round. Everything settles on Somnia, and every contract you're seeing is already deployed on live testnet. Now, here's the thing that makes the AI part unique. Every fighter runs on the same deterministic on-chain LLM, but each of them have their own system prompts stored on-chain. The degen takes aggressive positions while the quant waits for the mean aggressive. Like same brain, but the different personalities. Even a bookmarker is another agent continuously evaluating both fighters and publishing the live odds that the crowd can bet against. And Colosseum only works because Somnia brings all of these pieces together, the on-chain AI inference, Dreamrex, and reactive subcontracts, right? And of course, the subsequent finality. Take any of them away, and real-time AI versus AI trading simply isn't possible. Colosseum is already live today, real duels, real bets, and fully on-chain. I built Colosseum solo, building on the experience of my earlier 5 hackathons on Somnia, and of course 5 podium finishes as well. I believe this is a new category. AI agents compete, people predict the outcome, and the blockchain remembers every match. Welcome to Colosseum.
Very cool. Very interesting. We had this idea, but you've kind of materialized it of it's like financial AI products. I think there is something very interesting where if you take AIs and then financialize them, there's like new financial products that can be made, which I think you're kind of getting at here because you have this sort of AIs that trade against each other, and that's the counterparty that you're betting on essentially rather than the underlying asset. So you had kind of like 6 examples. Do you imagine people making their own trading AIs and then participating? What's your thinking there?
Yeah. We actually have that idea that people can actually mint their own AIs, that they can write their own system prompts, they can write their own personalities and how the market is behaving, and you can create your own profiles, mint them as NFTs, and now you have that part as well, that you deploy your own agents that trade for you in a competition.
Yeah, that's cool. That's very interesting. And then, so in terms of the kind of betting process, you basically you're doing kind of short-term markets. I think it's like the next 30 seconds, these two are going to battle, or is it longer term? What's the current the time frame that people are looking at?
So there are multiple arenas going on. Like you can create your own start. You can start your own rounds, and as a spectator, you can see all the matches that's going on. You can watch any match, and then you can bet how the things are going. The bookmaker is actually subscribed to Reactivity, so it watches every turns, and every 10 seconds it updates the scores on basis of which one is leading the game.
Cool, very, very cool. And then you currently have this on testnet, right? Not mainnet, or did you say you have this on mainnet as well?
No, this is right now on testnet only, because we didn't. DreamDex was very new to me. I was testing it. I was involved in the testing team, so that's why this was built in 1 week time, and that's why it's only on testnet, right? Because there wasn't a complete mainnet launch till then.
Yeah, makes sense. Very cool though. Yeah, I really like the project. I really liked how you've used a lot of the technology stack of Somnia, and then I like this idea that you've kind of tapping on, which is like financializing AI, allowing people to speculate on it. That's cool.
Thank you so much. Thanks for this opportunity as well.
Awesome. Thank you very much, Aditya. That brings us on to the final person now. We've got Daniel, who's going to be showing us his project, Sentry. So I think you've already joined us. Oh, no, you managed to share screen. That was very quick. Well done. Take it away. Last one.
Nice. Yep. Just to confirm that you can hear me fine. You can hear me?
Yeah, we can hear you.
Awesome. Yeah, so I am Daniel, and I'm presenting Sentry. So there is actually like a very big problem that's, as you know, plagued like every ecosystem, either blockchain or traditional ecosystems, which require like technological infrastructure, which is security. We have seen a lot of acts in the previous years of contracts that have actually been, hacked of funds based on, compromised private keys or just compromised access controls. And now that we now have this new paradigm of agents that want to be able to move funds or chain, or even like, do something more important on chain, then we need a guy that has to be able to, referee that particular, should I say, behavior before it actually lands on chain. And here is Sentry. Sentry was actually, should I say, it was actually I wouldn't say copy, but it was actually from the idea of Open Zeppelin Defender, which I used very well. But in this case, ported to work with AI agents also, like on-chain AI agents. So what is Sentry? Sentry is basically like an autonomous agent, also Bit-Centry that on Somnia, that actually sits between your agents and the blockchain itself. Currently, every agent can, sign any transaction. You tell it something you want to do, you give it an intent, and the guy goes around finding out how to do it, and it finally does it, right? But there's nobody in between that particular decision that, checks, oh, should you do this? Are you actually authorized to do this? Take, for example, you have a DeFi agent that, helps you rebalance your positions, right? And then you're like, oh yeah, just rebalance it every 24 hours. And let's say there's a little bit of a market itch. This guy wouldn't, know if he should actually hold off on that rebalance or, just follow through. So basically, this is how agents work currently. You have a goal. You send it to like an LLM, which converts that particular, unstructured data to structured data, and of course, converts that to call data. And since there's no guy checking, there's nobody checking if this call should go on, it lands on chain. Now, what does Sentry do? Now, Sentry makes a decision on chain, the same transaction as the call. Like it's also an agent in this case, so it acts to act in that same paradigm, like that same layer. So it sits like a man in the middle between the agent and, of course, the chain, and it decides if this particular call should actually go on or maybe it should be blocked. Now, it's actually very easy to integrate. It's just a modifier, but there are actually a lot of ways to actually integrate Sentry into your agent, either it's deployed already or not. Now, Sentry has 3 surfaces. That is like we can call them outputs in this case. We have the immediate output, which says, yeah, you can just run the call. It's fine. Yeah, it's safe. And then we have the delayed For most of us that have used NoSysAfe, or we have contracts that have this time locks, then this is similar to that, right? So if you have functions that you want to be delayed for a certain period of time before they actually execute, then this is what you should go for. And then we have veto. Veto is basically, yeah, I need you to sign off on this before I actually execute this. And I'm also planning to add more. Like I said, it was actually inspired by Open Zeppelin Defender. So this is what the UI of Sentry looks like. We have like a queue, and the queue literally tells you, oh, this is a particular call that actually requires your attention before I actually send this on chain. And of course, we also have the delayed ones. And for any call that runs immediately, then of course, it wouldn't be in the queue since it's already executed. Now, how Sentry works, the architecture is actually a little bit fluid because it depends on how you actually integrate it. When building Sentry, I noticed that a lot of agents might have been deployed. And since Sentry is supposed to act as a guardian, then it wouldn't work that way. So I thought of another way to build Sentry for agents that have already been deployed without actually integrating Sentry at the blockchain level. So now let's say we have a contract that is deployed already and has already integrated Sentry. You can decide to add function swap as an immediate function. That is, this function will definitely be called and executed. We have maybe the transfer function that will be delayed. And then we have the approve function that will need a veto, right? Oh yeah, I need you to sign off on this. And this is actually converted into a policy.md. The policy.md is like a Docker file. It actually has should I say, a semantic rule to it. So it has to actually compile before it can be passed on to Sentry, which actually enforces it. And then you publish to an Oracle. After you publish it to an Oracle, this policy is actually public. You can use it. You bind it to your agent, or anyone else can literally reuse it. Now, these are the surfaces I was talking about. The way Sentry works is you can actually integrate it on the smart contract level to sit in between your agent contracts and, of course, the blockchain, or you can integrate it on the front-end level. But that is, it just checks the front-end calls that is being made. Now, we have the watch mode, and the watch mode is if you just want Sentry, according to its name, to just watch. It should just give you alerts. This is like one of the best modes I love in Open Zeppelin Defender. It's like you set a type of guardian on your contract, and it just looks, oh yeah, something is going wrong, and it alerts you immediately. So like either through Discord, Telegram, or any social tunnel that you want. So this watch mode is for guiding agents that you can't change. So basically just notifies you. Then we have the CLI, and this CLI is like say a developer should I say power station in this case. It allows you to publish and inspect from your shell directly. Say you don't want to use the UI, you can compile your policy.md. You can actually simulate what would happen if it was actually deployed on chain, and so on and so forth. There's also a TUI monitor, since the age of TUI is here with all the coding harnesses and stuff. And finally, you have the SDK, which is for the front end. So if you have a front end and you don't want some on-chain calls to be made, or you want Sentry to check these calls out before they actually dispatched, then you should actually use the Sentry SDK. And finally, I'm actually looking to add these guys, like the webhooks and alerts, which is very, very important for agents that you do not have a lot of control over. A policy library, of course, we have a lot of policies that can be reproducible for different other agents. We have a committee veto. Of course, this is basically multi-sig. Multi-sig for agents in this case. And of course, I need to audit the code. That's the whole point. And yeah, these are the types of agents that you can use Sentry for: a DEX, a treasury, lending agent, staking agent, any agent actually. Somnia in this case is like a school where the agents are like students. So we need teachers. In this case, Sentry is the teacher. And finally, yeah, Sentry is deployed on testnet for now, because I'm not confident yet about the functions. I still need to add more to make it like a fully functioning guardian in this case, and you can test it out. Yeah, thank you very much.
Very, very cool idea. I never thought about using agents for this. So how do you kind of make the link between another agent and Sentry to make sure that it's kind of part of that loop, stopping things happening? How does that work?
Yep. Let me see. So basically, give me a second. So for the CLI, for example, let's say you have a trading agent that you are about to deploy, right, on Somnia, and you actually have to integrate the Sentry abstract contract first. This gives you it's like a very simple contract, and there's a policy ID. It's like sorry, not a constant. It's like just a variable in this case that you can set. And once your agent is actually deployed with that capability, then you can use the CLI, the Sentry CLI, or you use the UI to actually create your policy. And after it is created and of course published, you actually bind that policy to your agent. So basically, your agent needs to know the policy ID so that whenever any guarded function is to run, it checks the policy ID from the Oracle and sees if it actually can run or not in this case. So yeah, it is actually bound to the agent at runtime.
Very cool. Very, very interesting. But you have to be the owner, right? You have to be the original creator of the first agent. You can't bind this to any random agent, right?
Yes.
I'm assuming.
Yes.
Yeah.
Yes.
Yeah. Okay. Cool. Very interesting. Very, very interesting. I never thought about this use case. It's very useful.
Yeah, I wanted to say, like, if you're not the owner of the agent, right, that's the point of watch mode. So if you can't make a lot of like administrative decisions about the agent, you can still like, watch what this guy is doing and see, this is about. I mean, the reason why I found it a little bit interesting to do was because whenever there's like any suspicious activity on like big contracts, or maybe there's a hack going on Twitter, right, you see this notifications and they're like, oh yeah, so project, check your contract. And I'm like, how do you guys know something suspicious is going on? And even the projects don't. And then when I checked Open Zeppelin Defender, I knew how. So there's like webhooks, there's like notifications, alerts and stuff. And I was like, we should have this for agents. And also I run the AMS agent at home, like locally, and I know how many security guardrails are actually like built into AMS. So I'm like, we need to have this for on-chain agents. Yeah, so that's why.
Very cool. Very, very cool. Very nice. Very good project. And I didn't think about this at all, but yeah, it's super, super valuable and useful for the ecosystem. Yeah, very nice.
Thanks a lot.
Awesome. Okay, that wraps up the final pitch today. So well done to all the finalists who have managed to get through to this. We had nearly 800 builders in this hackathon, and between them, we started with about 260-ish projects, which turned into about 200, just under 200 submissions. So that's roughly 3 out of 4, every 4 projects, making it all the way to the finished submissions, which is a great and phenomenal completion rate really for this hackathon. So well done for all that. Along the way, we've run lots of different workshops. We've run how to build on Somnia, how to win a hackathon, to help you guys go the real distance of this. And out of these 194 submissions, you guys are the 10 which we have seen pitched today. So one more time, a huge congratulations to you guys. Let's get some reacts in the chat for you guys, because it's no mean feat to get through to this stage of the hackathon. I will hand over to the Somnia team now, who will let you guys know the prizes, who are the winners, and I'm sure they have more to say as well. But congratulations to everyone, and yeah, over to Paul or Anjali.
Cool. Anjali, do you want to announce the prizes and I'll announce the winners?
All right. Yeah. Thank you. I mean, I would say, I think all the projects today who presented are the winners. It's just that we are just announcing the project, the top 3 projects in the reverse order. But all of you have done great job. I mean, we have seen your progress right through for the last 1 month, and it's amazing to see what all of you have built. So for me, all of the projects, and even the projects other than the top 10 projects today, are the winners. Yes, so the top 3 ones, the number 3 project we want to award is Signal Vault. Amazing project.
Yeah, I think Signal Vault it's a very, very interesting idea and really helps the ecosystem and plugs into a lot of different component parts. I see a lot of use cases for it for retail traders being able to trade more effectively on the DEX, but I also can see expansions of it becoming just generally useful trading infrastructure for a lot of different people. Like this copy trading idea, I think is really cool. So yeah, I think Signal Trade has a really good base and then could really grow into something very, very interesting in the future.
Congratulations, Signal Vault. Number 2 position goes to Colosseum. Aditya, you always manage to win.
Yeah, I think, again, the reason for Colosseum, it uses a lot of the pieces of the technology stack, so reactivity, the DEX, the agent stuff, but it also is kind of scratching at a new idea that I've never really seen before, which is this idea of financializing agents and AI, being able to kind of speculate on them in some form or fashion, which I think is a very, very interesting idea that I've never seen anywhere before. But I think what's really cool about it is it uses like a foundation of data, which is like the trading data of like the DEX, which is really interesting, really cool.
Yes, agree. Congratulations, Aditya. And now for the top winner, I think we all saw that, and it's Sentry, number 1.
Yeah. Yeah, Sentry, it solves a problem which I've spoken about a lot internally of like, if you're delegating your trading to an agent, it could go mad and do crazy stuff. And this idea of having a layer of protection, I just saw it as kind of very valuable to the whole ecosystem. I think a lot of people built really cool apps for end users that solve, or for B2B customers that solve a real problem. This I kind of saw as like a component that could help the whole ecosystem in a very valuable way. And that's why we chose Sentry as number 1.
Yes. Having said that, there would be top 3 prizes, but of course, the other 7 projects would also get cash prizes. We will be mentioning the details on the Discord and Telegram communities for the pricing. Amazing job. I think I would just like to take a minute to thank everyone who was involved in the entire process of Agentathon, right from the DevRel team. Emre, I think he was the part of the DevRel team, very active on the Telegram community, supporting the devs and, with all the technical queries. So thank you, Emre, for your support. The Encode team, again, you did a great job. Thank you so much for all the support and executing it so smoothly. Paul, for your presence today and your valuable inputs. I think projects would get a lot of valuable inputs. And to all the great participants here, I think some of you have joined, some of you can join and can watch this recorded session later. But I just wanted to mention one aspect, that the hackathon is not an end to the journey, which we have started. It's like the beginning for us. So as the DevRel team, we would be initiating a lot of other programs where we would want to see you take your project into another heights, like become part of the ecosystem, and we're ready to support you in different ways. We're going to, start a Discord showcase series where you will get a chance to present your project to the community, get feedback, and we would see, the best ways which we can move forward. And this is applicable to not only the top 10 projects which presented today. There are some other very cool projects which we identified could be a very valuable addition to the ecosystem. So thank you all for contributing to our ecosystem. And yes, we look forward to working with you continuously on really cool activations coming up in future. Thank you so much.
Yeah, awesome work, guys. I really love to see all the innovation, use of the tech stack, amazing projects, new ideas that we'd never seen before, which is really what we wanted to get out of this, and some very cool projects. And I would really hope a lot of people try and continue their projects afterwards, because I think some of them could be very, very interesting in the market and get a lot of adoption from the crypto crowd.
Thank you. A bit
Awesome.
more
Yeah, thank you very much, guys. Oh, yeah.
On the hiring process, since we mentioned it's a hackathon, we're very much in touch with all the CVs and project demos and everything. So I think the top there would be finalists for the demo engineer role, and we would be reaching out to them in the next week for one interview round. And yeah, we will take it forward from there. Thank you.
Perfect. Okay, thank you very much to absolutely everyone who's been involved in this, whether you've been a participant or the Somnia team. It's been great working with you guys. And yeah, like I said, we've had a huge influx of submissions. So congratulations to all the finalists. Keep building, keep up with Somnia ecosystem. If you want to do more hackathons, Encode are always hosting online events. Just go out and check the programs page and sign up to other ones if you want to win some more prizes. I'm sure if you've won today, you're more than capable of winning something else in some other hackathons as well. So congratulations to everyone. And that wraps up the last few weeks. I will do a Discord announcement so you guys are aware of who has won what prizes. I will also send you guys all an email. If you could reply to that email and let me know your wallet information, I will get on with prize distribution and hopefully make you guys all happy. But yeah, thank you very much, guys. And I will hopefully see you in the next hackathon.
Thank you.
All right.
Cheers.
Bye-bye.
Thanks all.